So to begin with, what you're doing, we've done a lot of problems like this, and part of the purpose of this is an overview of what we learned in trig and just adding in the new identity. So your job is to find the cosine of 2 theta. If you're asked to find the cosine of 2 theta, you need to usually immediately go right to one of the identities. So, and I only remember one of the 3 identities, so this is what I do, is cosine of 2 theta. This is the one that I remember, so you want to go ahead and write this down. That's cosine squared theta minus sine squared theta, like that. That's an identity. So if we solve this problem, that's ultimately going to give me an answer. So if I can figure out cosine squared theta and sine squared theta, I got it. However, now I have to do this in my head, but I'm going to go ahead and show you. You can write this down if you want to, or you can just pay attention. That is one of the identities. That tends to be the one I remember. But you could also change the cosine to 1 minus sine squared theta, because that comes from sine squared theta plus cosine squared theta equals 1, right? Okay. So see, I'm deriving the other form as I go. So that's 1 minus sine squared, 2 of those, because you have like terms. So what you have is 1 and 2, that should be 1 minus 2 sine squared theta, like that. That's the identity I'm going to use on this problem, and let me explain why I'm going to do that, okay? So does that make sense? So I took the basic identity and got the next form of it. You know, there's 3 forms of this identity. Now, here's the thing. I'm going to use this identity instead of that one. Any idea why? What did I give you? I gave you the sine. So what's the point in me having to go through and get a cosine to use that identity? All I need is the sine in this one. So that's beneficial if you see stuff like this, because it saves you a little bit of time. So that's why I'm going to do that. Okay, so what we're going to do then is, in this problem, you're given the sine of theta is equal to 15 over 17. And this we have seen over and over again. You get to this point in the class, you start seeing a lot of repetition. The sine, remember, is y over r. Okay? That we are in quadrant 1 because that's what that statement says. You're between 0 and pi over 2. So that means everything's positive. So we'd have 17 for the radius, 15 for y, and then you just got to use the Pythagorean theorem to find x. Okay? But it doesn't really matter on this problem. If you look at this, it doesn't matter that I figure out x, because I already got what the sine is. See, that's 15 over 17. So all I got to do to solve this problem now is just do this. So the final goal would just be cosine 2 theta equals 1 minus 2 sine theta squared, but the sine theta is 15 over 17. So all you got to do is work that arithmetic problem out. Does that make sense? Okay. So if you're wanting to find cosine of 2 theta, look at the identities and pick one of the 3 forms. If you go to the previous page, you'll see those 3 forms on there. I use the sine because I already have a sine. Does that make sense? Yes or no? Tell me. Okay, that's why I'm using that identity, because it's easier. Okay, so that's going to be 1 minus 2. If you square 15, that's 225. This one I think is 289. The calculator takes 17 times 17. I don't know if I'm right. I think I am, though. Let me just double check real quick. So let's see, 17 to the second. I know it ends in 9. There we go. Okay. So now let's get a common denominator, basically. So I'm going to change the 1 to 289 over 289. I'm going to multiply this fraction straight across. So that's going to be 450 over 289. And then I can take my calculator, and then I got an answer to this problem. So I'm going to go ahead and just do that on the calculator. So 289, and then subtract 450 will give me an answer of negative 161 over 289. Okay, that's the idea. Okay, you got to get some weird answers with these problems too sometimes. So the idea, really the purpose of this problem is to help you begin to get comfortable with that identity. The double angle identities, you tend to use those more in proofs and simplifying expressions. You don't tend to use them as much for finding angles, but I want you to know how the identity works. Okay, is there any question about what I did on that problem? Okay, it's arithmetic primarily. I gave you what you needed to know to solve that problem. Okay, next one we're going to do the tangent of 2 theta. So again, when I look at this, if I want to find the tangent of 2 theta, I'm going to go directly to that identity. Okay, and I'll back up a couple of pages. This one is, I think, 2 tangent theta over 1 minus tangent squared. So we're going to use this identity right here. Okay, 2 tangent theta minus 1 over tangent squared theta. That's going to tell us how to do the problem. Okay, so I'm going to go back to that page and let's write that identity down, and then we'll kind of follow along what we need to do on that. So tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. Okay, so what we need to know really to solve this problem, we got to know 2 things. We got to know what the tangent of theta is, like that. That's it. Okay, and then we got to square that, and we work out arithmetic, and we got it. So I've given you enough information to figure that out. So that we've done this lots of times this semester. Okay, I gave you the sine of theta is negative 4/5. So which 2 letters did I give you based on the definition? Tell me. Y over R, right? Okay, got to go back those definitions. If you don't know your definitions, you got to get them down. Okay, so that's Y over R. So R is 5, Y is negative 4. Okay, so we got that. All right, now we got to find the tangent. So if we're going to find the tangent, we got to do y over x, right? Because that's what the tangent is. So we need to know what x is. Do you know what that is without having to do the Pythagorean theorem? 3. That's a 3, 4, 5 right triangle. But we got to make sure that we pay attention to the quadrant to make sure we have it right. Okay, so it looks like this is telling you you're between 3 pi and 2 pi. So you're definitely in quadrant 4, so that means that x is positive. We've done everything we need to know to figure out how to do the problem now. Okay, is everybody with me on that okay? Okay, now what is the tangent of theta? Tell me what that is now. Negative 4 over 3, good. Okay, so that's negative 4 over 3 because it's y over x. Okay, so now I'm ready to just get going with the arithmetic. So the tangent is negative 4/3. So I'm going to plug that in like that. And then the denominator is 1 minus negative 4/3 to the second. So I need to just crunch out the arithmetic and then I've got it. All right. So what I'm going to do on this one is multiply the numerator straight across. So that's negative 8 over 3. The denominator, I'm going to square the negative 4/3. You can do that in your head. So that's going to be 16 over 9. Okay? Now, when you see an expression like that, you got to learn to do this the fast way. Okay? I mean, there's more than one way to do this. One way is you could get a common denominator, put that together, and divide. What I tend to do on this is 3 and 9. The common denominator of 3 and 9 is 9. So I'm going to multiply the top by 9 and the bottom by 9. That's one way to do that. That's just kind of what I typically do. So that will get rid of these fractions. So let's do it this way. Let's multiply the top by 9 and multiply the bottom by 9. Okay? And if you do that, one of the benefits of this is it gets rid of your fractions. So basically 9 over 3 is going to be 3. And then negative 8 times 3 is negative 24, like that. Do a distributive property. 9 times 1 is 9. And then those will cancel out, so that's 16. That's just the way I like to do it. To me, it's just simpler. So that's negative 24 over, what is that, negative 7? So the answer is 24 over 7, like that. Okay? Now, there's a couple of things that I want to mention on here. And this is sometimes a student will wonder about why the answer is positive. So let me explain that a little bit. Okay, first of all, our angle, we're in quadrant 4. That's where the angle is. And the tangent is actually negative in quadrant 4, but that's not what we're finding. We're finding the tangent of double that angle. So I want you to think about this. If you have a quadrant 4 angle and double it, okay, that actually changes something on that. So it's not really in quadrant 4 anymore. So what's really happening in the problem, I'm going to show this with a calculator, is, and I'm going to use degree mode in my calculator to show you this. So So let me get that put in. So what I'm going to do is I'm going to do this. I'm going to find the angle by doing the inverse sine. So if I go inverse sine of -4/5, that's going to give me the quadrant 4 angle like that. So that's -53. That's what that angle really is. Okay, and then if I double that, okay, what I end up having on that is -106, like that. Okay, and then I want you to think about this. Where is a -106 degree angle? What quadrant are we in now? 3, right? Okay, that's where we really are after we double the angle. So do you remember the tangent is positive in quadrant 3? That's why I got a positive answer. Does that make any sense? Okay, we did not find the tangent of theta. We found the tangent of twice theta. So the mathematics all works out and gives you the right sign on there. Does that make any sense? Okay, you are doubling the angle. So you're not in quadrant 4 anymore. You're in quadrant 3. That's the idea. All right, any questions on that with anyone? Okay. Okay, now let's see. I'm going to work a little bit more with this, just something with composition of functions for something a little bit different. And then I'm going to do a little bit of work with half-angle identities, the other main thing that we want to learn in this section. Okay, I think on this one, I've given you a couple of diagrams. This one is kind of nice to go through because it goes back to a little bit of college algebra stuff too, and pre-calc stuff. So what we're going to do on this problem, based on these diagrams, we're going to find what f of 2 alpha is. Okay, you're given the function f of x is sine of x. Okay, so what you're really doing in this problem is you're going to do the sine of 2 alpha. And the diagram, you have to look at that diagram the correct way to figure that out. Okay, so if you're trying to find the sine of 2 alpha, the first thing you need to think about is identity. What's the identity for that? So I'm going to write that general identity down. You can write it down if you want to, but you don't have to. The sine of 2 theta is 2 sine theta cosine theta. Okay, that's your identity. Okay, so what I'm going to do is I'm going to write this down like this now. I'm going to change this to 2 sine alpha times cosine alpha like that. Okay, so all I'm doing is just looking at what that function is that I'm supposed to find, and then I'm using that identity. Okay, so now what we need to do is we need to look at this diagram right here. This second one doesn't have anything to do with that problem, so this has got the angle alpha in it. Okay, so what we have to do is, based on that diagram, we have to figure out what the sine of alpha and cosine alpha is. That's it. That's all we got to do. Now, this thing right here is not a unit circle. Okay, first of all, let me ask you this. From your background, let me just see, some of you will know this right away, some of you may not. What is the general x squared plus y squared equals 7? What kind of function is that? It's not a function. What kind of graph is that? That's a circle, right? X squared plus y squared equals r squared is the equation of a circle with a center of 0, 0. Did you learn that in college algebra? Okay, so what that means is it really means this. This is the general form that you generally learn in college algebra. So that thing right there is r squared. That's what the radius is. This isn't a unit circle. So you would have r squared is equal to 7. So therefore, that radius is equal to square root of 7. And in this problem, the radius is essential to figuring out what I need to know in the problem. Okay? So now what I'm going to do is we need to find x and we need to find y. The basic idea behind this is if we're going to find the sine, we got to know what y over r is. If we do the cosine, I need to know what x over r is. The reason I'm not just saying, okay, the sine is y and the cosine's x is because that's not a unit circle. You see what I mean? Okay, so we have to find x, y, and r to finish this problem up. But we got all the information that we need to find if you look at this diagram correctly. So notice in this problem, they gave you y. I have to give you something. So y is going to be square root of 3. Now we're down to Pythagorean theorem again, aren't we? So we need to go ahead and get that finished up. So let's solve that. So we're going to have x squared plus y squared equals 7 is our general equation you were given. So we have x squared plus square root of 3 squared is equal to 7. I'm just using that equation. So that is x squared plus 3 equals 7. You can subtract 3 from both sides to get 4. Square root both sides, you're going to have x equals plus or minus 2. Okay, well, which is it? Minus. Okay, that's because of the diagram. Okay, we're in quadrant 2. That angle alpha is in quadrant 2. So you want to be sure that you use the negative 2 on that then. Now we're ready to finish. Okay, so one of the key things you got to know is you had to know that x squared plus y squared equals 7 is a circle. Okay, is there any question about that from your background? Okay, now we're ready to finish up the problem. So it's real easy from here. The sine of alpha is y over r. So that's going to be square root of 3 over square root of 7, like that. The cosine is x over r. So that's negative 2 over root 7, like that. Multiply it out. Looks like the numerator is negative 4 times square root of 3. What's the denominator? 7. Square root of 49 is 7. So that's it. Okay? All right. So that one is basically looking at the double angle identity in terms of something that's not a unit circle. It's just a general circle. Okay, like that. Okay? Is there anything that you don't understand on that? Okay? Yes or no? I don't know. I'm seeing spring break looking faces out there today. Okay? All right, I'm excited too because I don't have to work either, but I have to grade a ton of papers. Okay, let's do, I think what I'm going to do is maybe one additional one of these down here at the bottom just for a little bit more practice of this idea. So the idea is g of x is cosine. So when we get into this problem down below here, we're going to be doing g of 2 alpha. Well, g of x is cosine, so what we're really going to be doing is cosine of 2 alpha. And we've already got a lot of the details of this problem done that we need. So I'm going to slide this up to the top. I don't really need that circle diagram anymore. What I really need is I need this. I need x, y, and r. That's the whole work of the problem, is doing that. The rest of it's arithmetic and identities. Okay, so remember when you do a cosine of 2 alpha, you have 3 possibilities. Okay, now I'm going to scroll back to page 1, but I'm going to come right back. Just for reference, this right here, that is your 3 identities right there. You take your pick. It doesn't make any difference to me. If I was doing this problem, I would bypass the first identity. You know why? Because I have to know both the cosine and the sine. But you can pick it if you want to. Just for something different, I'm going to pick this identity, 2 cosine squared theta minus 1. I'm just going to make a decision. That's the one I want to use. Okay, so let's use that one. Okay, so let's write that down then. That is 2 cosine squared alpha minus 1. And now we're ready to roll. Okay, because see, all we got on this is, if you look at this information right here, well, what's the cosine? The cosine is negative 2 over radical 7 because it's x over r, right? I already got x, y, and r. I already did all the work of the problem. So this is going to be 2 times negative 2 over square root of 7 squared minus 1, like that. Okay, and then from here I'm going to just do the arithmetic. So that's 2. If you square this out, what does that give you if you square that out? Just in your head real quick. 4 over 7, right. You square the negative, you get 4. Radical goes away. Okay, so that's going to be times 4 over 7 minus 1. Okay, so if we finish that up, put that over 1, that's going to give you 8 sevenths minus 1, and I'm going to change the 1 to 7 over 7. So it looks like I get 1 over 7 is what the answer to that is. Okay, like that. Okay, so that's the idea. Once you got x, y, and r, you got it made. You just got to pull out the identity. That's the idea. Okay? All right, is everybody following along? Okay. Okay, vast majority of this is the arithmetic once you get the identity written down. Okay, now on the next part, I'm going to do this one real quick. This is tangent. So if you look at the top of the page, this is telling you that h of x is equal to the tangent. So h of 2 alpha is really going to be the tangent of 2 alpha. So we're going to find tangent of 2 alpha. So what we're going to do is we have to do the identity. Okay, so you got to look up that identity for tangent of 2 alpha. Okay, that's on page 1. What that is it's 2 tangent of alpha So let's write down the identity. The identity is 2 tangent of alpha all over 1 minus tangent squared alpha, like that. Okay? Now we got everything we need to know, so let me ask you a quick question. Very simple. What is the tangent of alpha going to be? Y over x, so that's negative square root of 3 over 2, right? Okay, so we got that. Let's plug it in. Okay, y over x, so that's going to give us 2 times, and it looks like it's negative, so that's negative square root of 3 over 2. And then the denominator, we just do this. We do 1 minus negative square root of 3 over 2 squared, like that. So that's the arithmetic we're going to do. Okay, keep it simple. Notice that the 2's cross out. That's kind of nice. I'll move this up here. So that's going to be negative square root of 3 in the numerator. The denominator, just do this in your head. What's that? Negative root 3 over 2 squared. Positive 3 over 4, right? So that's 1 minus 3 over 4, okay, on that. And again, what I'm going to do is get rid of the 4, okay? Instead of doing a division problem and that way, I think you're better off if you just learn to do this way. That's a complex fraction, so make that 4 go away, okay? And when you do that, looks like you're going to have negative 4 root 3 in the numerator. The denominator, you have 4 times 1 is 4. Because I'm doing a distributive property, 4's cross out, you get that. So it appears that I have negative 4 root 3 over 1. So the answer of the problem should just be that then. Okay, so that's just an exercise in working with those identities. That's the main idea behind that. Okay, what do you think about that? Is that reasonable what I'm doing on that problem? Okay, I do one of those in the homework. It's just something a little bit different with a circle, and kind of makes you review the college algebra, the equation of a circle. Okay? All right, any questions? Okay, now we're going to look at half angle identity next. The half angle identities, I'm always going to give these things to you. So even all the identities in this section I always give you, and I don't require you to memorize. If you're going to go through calculus, and I know many of you are, like when I teach calculus 2, we actually use these half angle identities right here all the time. So we use these constantly in Calc 2. So I make sure my students memorize those when they get to Calc 2, but you don't have to in this class. So what we're going to do most of the time is we're going to use these identities right here. Okay, if you want to find the sine squared alpha over 2, that's the one I'm going to use the most. And then, not that one, this one. This one is the one you're going to use the most, and you're going to use that the most. And then this one, you guys need to write this down. And let's see, I think like I may have to Google something on this one. This is hard to derive. But I think it's 1 minus, no. I'll look at something too. I'll look it up here in a minute. It's 1 minus cosine alpha over sine alpha. You want to write that down. That's important. That is right too. So I can kind of think in my mind where that comes from. If I ask you to do a tangent of alpha over 2, don't use that identity. I would suggest that you write a note to yourself. Don't use that, use that. There's actually 3 forms of that identity, but this is way easier than that. If you do the problem that way, it's really complicated. So I would recommend that you write this down, and this is the one that you want to use. That's the good one right there. That's the one that's just kind of not worth your time, okay? Those things are mathematically equivalent to each other. All right, so what I'm going to do is show you what we use half angle identities for. One thing we use them for. We can actually figure out the exact answer to the sine of 22.5. That certainly doesn't fall on the unit circle, but this half angle identity will allow us to get that answer. So it works like this. Let's write down sine of 22.5, and we're going to use this identity right here that I'm circling. So what we do, when you do a half angle identity, first of all, you want to double that angle. So if you doubled that, you would get 45. And then you want to write that as 45 degrees over 2. So you want to write it as alpha over 2. Okay, 45 is a special angle, right? That's unit circle stuff. So by using the identity and our knowledge of the sine of 45, we can get the exact answer of the problem. Okay, so the first thing let's do, let's write down the identity before we do anything with this. So it's plus or minus the square root of 1 minus cosine alpha over 2. That's what the identity is leading us to do. And then on this identity, there's always a couple of things you need to know. You need to know which one to use, plus or minus. Well, it's very simple. That is a quadrant 1 angle, right? So what do you expect the answer to be, positive or negative? Positive. You always look at that angle. Then look at that angle when you make that determination. Okay, like if that was the sine of 300, then that would be negative, right? Okay, everybody with me on that? Okay, so that's positive. Now what we're going to do is we're going to work this out like this, basically. Next step we want to write is like this. We know that's positive, so I'm going to put that there for emphasis. And then we say 1 minus the cosine of this. Okay, see, the identity says cosine of alpha. Alpha is this. Okay, it's not 22.5. So you put in cosine 45 degrees over 2 like that. Now you've got everything you know. You know what the cosine of 45 is. Then the rest of this is some algebra and basic arithmetic. Does that make sense to everybody? Okay. All right. Most common mistake that students make is they want to put 22.5 there, and you want to put 45 in there. That's what the identity tells you to do. Okay. Do you guys have cosine of 45 memorized by now? God, I hope so. What is it? Square root of 2 over 2. Usually by now students know that. Piece of cake. That's good. Okay. So that's 1 minus square root of 2 over 2 all over 2. Now the rest of this problem, we just got to talk about the way you handle the algebra. And you get a weird answer on this problem. It's okay though. So what I look at in this problem is I just don't want that 2 there. Okay, so to get rid of that, I'm going to multiply by 2. So I'm going to multiply the top by 2 and the bottom underneath the radical. So you're not doing anything incorrectly mathematically by doing that. So you can go under the radical, multiply that by 2 as long as you multiply the bottom by 2. That way you're not changing the problem. Okay. Now when we do this, watch carefully, I'm doing a distributive property. So I'm going to have 2 times 1 is 2. And then when I multiply this out, the 2's are going to cross out, leaving you square root of 2. And then the bottom is now square root of 4. Okay? So now the only other thing you can do on this really that I want you to do is the square root of 4 is 2, right? So you can take that out of the radical. So you would end up with this answer, square root of 2 minus square root of 2 all over 2. Okay, you can write the answer that way, or you can write it as 1/2 square root of 2 minus root 2. They're both, of course, the same thing. So that's it. So this is something maybe you've never encountered before. You can have a radical under a radical. Okay, there's nothing wrong with doing that. You are rationalized, that's the key thing. So we don't go any further with that. We stop at that point right there. Okay? All right, you guys follow the arithmetic that I did working with that radical. Okay? It's a weird looking answer, but in higher math, like in calculus and stuff like that beyond, you start seeing radicals nested in with radicals infinitely. Okay? There's no limit to it. Okay? So the idea is there's nothing wrong with that. That's pretty common actually. Okay, so is there any question about anything I did with that half angle identity? Okay, I'm going to do probably one more of these, and then I'll do the tangent. I want to just do one of each. So the next one, what we're going to do is we're going to work with the identity. So the way I remember this, and again, I'll give you these identities. The only difference between the sine and cosine half angle is that thing changes from minus to plus. So on the problem we're going to do, that's just going to be a plus. And you can, again, look that up. So let's write that identity down and then finish this one up. So what we're going to do on this, to the side, I'm just going to write down cosine alpha over 2 is plus or minus 1 plus cosine alpha over 2. Those of you who go to calculus, you'll when you get there, if you're going to go to Calc 2, you'll do this, use that identity a lot, okay, on what we call integrals. So we're going to write this like this. When we do cosine of 165, the first thing that you want to do is you want to change it into this form, alpha over 2. So you want to double this angle, And let's see, that I think is 330 if you do that. So let's go ahead and write that as 330 degrees over 2. Okay? And the thing is, 330 is on the unit circle, right? 165 is not a special angle, but 330 is. So by doing that, we can use this identity to get the precise answer, see? Okay? So now let's use our identity. And you've got to be kind of careful with this now. You've got to figure out if that's plus or minus. Okay, look at that angle. What quadrant are you in? 2. What's the cosine in 2? Negative. So we're going to use the negative. You got to pay attention to that. To me, that's the first thing you want to do on the problem is make sure that you know that since that's a quadrant 2 angle, you got to use a negative. Okay. So now when we plug this in, we're going to have, let's plug it in over here. We're going to have negative square root of 1 plus the cosine. Which angle are you going to use, 165 or 330? 330. I ask that question all the time because that's where students mess up. All the time. So that is 330 degrees, okay, like that, and then all over 2. And then we're ready to go to the unit circle and perform the arithmetic to simplify it, okay? All right. A lot of times when I've been teaching, I've been kind of having a unit circle at the side. I'm going to try to wean you off of that a little bit now because if you're in higher math, like when I teach calculus and classes beyond that, a lot of times it just pops up. Okay, and you don't go scrambling and Googling a unit circle. You just figure out the point that's necessary right now. So what I do is I know that 330 is in quadrant 4, and I know it's this point right here. And it's real simple. The way I remember this, I've shown you this before, is the x value is big. So what does that have to be then? Square root of 3 over 2. The y value is small, so what is that going to be? Negative 1/2, right? So I do that all the time. I know the one in the middle is root 2 over 2, right? You probably got that down by now. And then the other two are flipped, so I just reason out where it is in the unit circle. So that is going to be square root of 3 over 2 there and negative 1/2. Okay, so that means when we do the cosine of 330, that's going to be square root of 3 over 2. Okay, so now we're ready to plug that in and simplify to get our solution here. So that's negative square root of 1 plus root 3 over 2 all over 2 like that. Okay, and then the same thing that we did on the last problem, the idea is you want the 2 to go away. So what are you going to do? Multiply by 2 over 2. Okay, that's the idea. Okay, so you want to go ahead and take care of that. And then these problems generally work out about the same way. So I'm going to multiply by 2 on the top, and then 2 on the bottom to keep from changing the problem. Okay, so that's going to end up giving me 2 times 1 is 2. Okay, that crosses out, leaving square root of 3. Then 2 times 2 is 4. And then you're going to typically find on these problems you end up with that 4 in the denominator. So you can write your answer as negative square root of 2 plus the square root of 3 all over 2. That's the way I usually write it. It's like that. Okay? That radical 3 is under the bigger radical. That's the idea. Okay? Okay, any questions about that? Okay, that's also a problem that could be verified on your calculator. You could take the cosine of 165. You could put that expression in your calculator, and it'll give you the correct answer in decimals. So it can be verified that way. Okay? All right, so is there any questions with that? Okay, everybody following along okay? Okay. All right. Now we're going to do a tangent. I just want to do one of each. So the tangent, and I think this is real important that when you do a tangent half angle identity that you use that one. Okay? This one's got a square root, and it really makes the algebra incredibly difficult. And this thing doesn't even have a plus or minus in it. So really all you got to do is figure out cosine and sine. It's a real simple expression, so you want to do that. Okay, so let's work with that identity on this problem. So I'm going to write that off at the side. We have tangent of alpha over 2 is equal to 1 minus cosine of alpha all over sine of alpha. Okay? All right, so what I'm going to have from here is, first of all, if you want to do this, you got to figure out what you double to use this. So I'm going to leave this. You can change it if you want to change it to degrees you can, but you don't have to. Okay, you can just double it and leave that in radians if you want to. I think students usually see it a little bit better if they look at this in degrees, and this one's going to have a 0.5 in it. I think this is 157.5. If I calculate that out, I just want to make sure. Yeah, that's right. Okay, so let's work with the tangent of 157.5 degrees like that. Okay, so that's what we're going to work out using this identity right there. Okay? All right, so the first thing you want to do is you want to figure out what angle you're doubling, or what angle you cut in half that would give you 157.5. So while I got my calculator out, I'm going to go ahead and double that angle, and then that's going to be 315. Is 315 on the unit circle? Yes, okay, that's why that's a good angle to use this formula for. So we write this as 315 over 2 like that. Now we're set up and ready to go. Right, everybody okay so far? So always do that same thing. Double the angle to use the half angle identity. Okay? All right, now we go over here and use this identity. So that's going to be 1 minus the cosine of 315 degrees. Okay, and then it's going to be all over the sine of 315 degrees like that. That's what you got to work out. The rest of it is unit circle and arithmetic. That's it. Okay? Okay, so let's see. We know that we're in quadrant 4. 315. What is the point on the unit circle at 315? Root 2 over 2 and negative root 2 over 2. It's in the middle. Okay, so that's the one that's easiest to remember. So we got that, and we're ready to get everything put together. So the cosine is going to be that. Okay, the sine is going to be that. Okay, let's plug it in, and then we'll do a little bit of arithmetic to finish up. So we're going to have, for the cosine, we're going to have root 2 over 2. For the sine, we're going to have negative root 2 over 2 like that. So that is an unsimplified answer. All right, does anybody have any question about what I've done? Okay. All right. Now, one thing that you'll kind of find on this too is that helps you understand a few things about this problem. That's a quadrant 2 angle, right? What is the tangent in quadrant 2? Is it positive or negative? It's negative, so we're going to expect to get a negative answer. And I can kind of see that happening. You're going to have a positive numerator and a negative denominator. Okay, so I like to kind of think of those things as I'm going through this. All right, so here's what we're going to do. I'm going to do this in 2 steps. First thing is I want to get rid of that 2, so I'm going to multiply top and bottom by 2. Okay, that will get rid of the complex fraction. I'm going to put it as 2 over 1. Okay, when you do this, be sure you do a distributive property. That's what students forget to do. So 2 times 1 is 2. Then this times that, we'll cross that out, leaving you square root of 2. And then down in the bottom, that leaves you negative root 2 like that. Okay? And then the other thing I'd want you to do is just rationalize that denominator. And I would probably also do this. Typically, we don't like to have negative denominators. So you can take the negative and move it to the top and distribute it through the top. That way you just have a positive denominator. That's usually what's preferred on this. So I'm going to do that. Let's just write this as negative 2 minus root 2 over 2. And and that's still a square root. Okay, distribute the negative through, and so you can do that in your head if you want to. So now that leaves us with the only thing we need to do is rationalize the denominator, then we're done. Okay, so we just need to multiply the top and the bottom by the square root of 2. Okay, so I'm going to multiply top and bottom by square root of 2. All right, so if I do that, I got a distributive property. That's going to be negative 2 times square root of 2. This is going to be square root of 4, so that's 2, right? The bottom, what's the bottom going to be? 2, because we rationalized, right? Now, am I done with the problem? What else do you see? Yeah, the 2's, okay? You can break that up. You can do this in your head. I don't care if you do this in your head, but what you're really doing is you're doing negative 2 root 2 over 2 plus 2 over 2, okay, like that. All right, so that is going to be negative root 2 plus 1, and then that'll give us the answer of the problem. Okay, that's the idea. All right, are you guys following the arithmetic? Okay, that's the part students sometimes struggle with, is that. Okay, does that look decent? Yes.
For the negative root 2 over 2 in the numerator and the denominator back on the fourth step on the left of the sign, could you just cancel out the root 2 over 2 since they're both in the numerator and denominator?
Okay, we're talking about right
there,
here.
yeah.
Okay.
Is it root 2 negative root 2 over 2 over negative root 2 over 2 just 1? Is that how that would work?
Oh, you're talking about from here.
No, just the next one over. So right where you were, the negative root 2 over 2 over negative root 2 over 2. If you do that, isn't that just 1? It's the same thing in the numerator and denominator.
Oh, you're thinking about maybe canceling those out?
Yeah.
No.
Isn't that way, right?
Well, I counter that all the time every time I teach this.
Yeah.
The reason you can't cross those out is because of that. If that was a time, yes.
That was a what?
If it was a multiplication of times. Okay. And I always kind of remind students that it goes like this. If you had something like 1 minus 2 over 2, let's just say you had that. So your theory is cross the 2's out and we get 1. That's your theory, okay? Actually, the answer to that problem is negative 1/2. Agreed? Doesn't work, okay? But here's the thing. If you looked at this problem, right, with a time sign, then you get negative 2 over 2, which is negative 1. It works. See, okay? That shows up in all the time in algebra, and you want to make sure that you pay attention and get that down. Okay, that's a typical mistake. You're not the first person who's ever made that mistake. Trust me. Okay, any questions? Yeah.
So how do you know when to use your half?
In general, that's going to be directed to you. Okay.
Yeah.
But in general, what you're kind of looking at, I picked these angles on purpose because when you double the angle, you get something on the unit circle. And 22.5 is not on the unit circle, right?
Yeah.
165, not on the unit circle. See, that's the idea. So typically, if you weren't directed to use the half angle identity, that's how you would know that that it's useful. Okay? 0.5s are kind of common. Usually the problems are predictable. About all I can give you is 22.5, 165, 157.5. There's a few other things that work, but that's the idea. Okay, does that make sense?
So it doesn't work for everything.
No, it doesn't work for everything. If I gave you sine of 2 degrees, you double that, you get a 4 degrees, you aren't going to get anywhere, right? Okay, that's the idea. Okay. Okay.